Hello, welcome to Nightlight Science Stories. Today, we dive into a mystery that connects the deepest trenches of the ocean to the furthest reaches of space. We often think of the Earth as a solid rock and the ocean as a simple body of water. But this is an illusion. Our planet is a giant electric generator, humming with a silent power that protects us from cosmic destruction. And surprisingly, the ocean is a crucial part of this machine. We call it the magnetic heart. It is an invisible shield that deflects the burning winds of the sun. But something is happening to this heart. The heartbeat is becoming irregular. The magnetic North Pole is racing across the Arctic toward Siberia, and a massive dent in the shield is growing over the South Atlantic Ocean. Are we on the verge of a planetary reset? Today, we unveil the shifting polar mysteries hidden in the deep. To understand the ocean's role, we must first look beneath it. Deep inside the Earth, 3,000 kilometers down, lies the outer core. It is a sea of molten iron and nickel, churning as hot as the surface of the sun. This movement creates the Geodynamo. Think of it as a bicycle dynamo on a planetary scale. As the liquid metal spins, it generates electricity, which in turn creates the magnetic field that surrounds us. For decades, scientists believed this core was the only source of our magnetism. But recent data from ESA swarm satellites has revealed a shocking truth. The ocean itself generates its own magnetic field. Seawater is salty. It is full of ions-charged particles. When the salty water moves in massive currents like the Gulf Stream or the tides, it conducts electricity. The ocean is literally a liquid wire wrapping the globe. This oceanic dynamo is faint compared to the core, but it is vital. It acts as a fine-tuner for the global field. The rhythmic pulse of the tides creates a magnetic heartbeat that can be detected by satellites in space. This means the ocean is not just a passive victim of climate change. It is an active player in the planet's electromagnetic health. It communicates with the core, creating a complex symphony of forces. But this symphony is changing. The distribution of heat and salt in the ocean is shifting due to melting ice caps. As fresh water from Greenland pours into the North Atlantic, it dilutes the saltiness. Less salt means less conductivity. We are effectively altering the electrical wiring of our planet's surface. Could these changes in ocean circulation be triggering the erratic behavior of the magnetic poles? The most visible symptom of this shift is the wandering North Pole. For centuries, the magnetic North hovered reliably over the Canadian Arctic. Sailors depended on it. But in the 1990s, it began to move. It picked up speed, racing at over 55 kilometers per year. It has now crossed the international dateline and is charging towards Siberia. It is moving so fast that airports have to repaint their runway numbers. This is not just a navigational annoyance. It is a sign of deep turbulence. The blobs of magnetic flux deep in the core are fighting a tug of war. A massive patch of magnetic strength under Canada is weakening, while a patch under Siberia is strengthening. The North Pole is essentially being sucked across the ocean by the subterranean battle. The stability we took for granted is vanishing. Why should we care if the compass points slightly wrong? Because the magnetic field is our only defense against the sun. The sun constantly shoots a stream of radioactive particles called the solar wind. Without our magnetic shield, this wind would strip away our atmosphere, boil our oceans, and sterilize the surface. Mars lost its magnetic field billions of years ago, and look at it now, a frozen dead desert. The magnetic field is the reason you can breathe. It deflects the solar radiation around the planet, channeling it safely to the poles where it creates the beautiful aurora borealis. But as the poles shift and the field weakens, the shield develops cracks. We are already seeing the effects. Satellites passing over certain areas are being bombarded by radiation that shouldn't be there. This brings us to the South Atlantic Anomaly, SAA. It is often called a pothole in space. Located over the ocean between South America and Africa, the magnetic field here is drastically weaker than the rest of the planet. It is expanding westward and splitting into two separate lobes. When satellites like the Hubble telescope pass through this zone, they have to shut down their sensitive instruments to avoid damage. The SAA is like a bruise on the Earth's protective skin. It allows cosmic radiation to dip dangerously close to the atmosphere. For the astronauts on the International Space Station, passing through this anomaly means receiving a higher dose of radiation. It is a window into a potential future where the entire global field collapses. Is this the precursor to a full geomagnetic reversal? To know if a reversal is coming, we must look at the past. And the history book is written on the ocean floor. When underwater volcanoes erupt at mid-ocean ridges, the lava cools and solidifies. As it cools, the iron minerals inside align with the magnetic north like tiny compass needles. Once the rock hardens, that direction is locked in forever. It is a magnetic tape recorder. By studying these magnetic stripes on the seabed, scientists discovered that the Earth's poles have flipped hundreds of times. North becomes south, and south becomes north. This process takes thousands of years and is chaotic. The field weakens, becomes multipolar, with several north and south poles popping up randomly, and then reestablishes itself. The last flip was 780,000 years ago. We are overdue. If a reversal happened today, the consequences would be far more severe than in the Stone Age. We are a civilization built on electricity. A collapsing magnetic field would expose our power grids to solar storms. A single massive solar flare, like the Carrington event of 1859, could fry transformers globally, plunging us into a darkness that could last for years. The internet, GPS, banking, all gone. But the ocean offers another clue. The conductivity of the ocean might actually help stabilize the field during a reversal. Some models suggest that the electric currents in the saltwater act as a Lenz's law brake, slowing down the rapid changes in the magnetic field. The ocean might be the buffer that prevents a total collapse, absorbing the electromagnetic shock like a giant saline sponge. The impact isn't just technological, it's biological. Many marine creatures, whales, turtles, sharks, and salmon possess magnetoreception. They have tiny crystals of magnetite in their brains or noses that allow them to feel the magnetic field lines. It is their built-in GPS. They use it to migrate thousands of miles across the featureless blue abyss to find feeding grounds and mating sites. As the poles shift and the SAA grows, these animals are getting confused. There have been increases in whale strandings in regions where the magnetic lines intersect with coastlines in new ways. They are following a map that is being rewritten in real time. If the poles flip, their ancestral migration routes could lead them into deadly waters or barren deserts of the ocean. The ocean holds the secrets, but it guards them well. We have better maps of the surface of Mars than we do of our own ocean floor. To predict the future of our magnetic shield, we need to go deeper. We need to understand the coupling between the fluid ocean and the fluid core. The magnetic heart is beating, but is it an arrhythmia or a natural cycle? In the next part of this documentary, we will dive specifically into the South Atlantic Anomaly. We will explore why this weak spot is growing, the strange radiation phenomena observed by pilots flying over it, and the terrifying possibility that this is the epicenter of the next great polar flip. The dent in the shield is getting deeper. The South Atlantic Anomaly is often misunderstood as a hole. It is actually a dent. The Earth is surrounded by the Van Allen radiation belts, donut-shaped rings of trapped energetic particles. Usually these belts stay thousands of kilometers above us. But over the South Atlantic, the Earth's magnetic field is so weak that the inner radiation belt dips dangerously low, reaching down to just 200 kilometers above the ocean's surface. This means that for satellites and spacecraft orbiting in low Earth orbit, passing through this region is like flying through a radioactive storm. NASA officially calls it the Space Bermuda Triangle. It's a zone where the rules of safety no longer apply. The radiation here is thousands of times more intense than anywhere else in the same orbit. It is an open wound in our planetary defense. The most chilling evidence of this anomaly comes from the astronauts themselves. When the International Space Station passes over the South Atlantic, which happens several times a day, astronauts report a haunting phenomenon. Even with their eyes closed, trying to sleep, they see sudden, bright flashes of white or blue light dancing in the dark. These are not dreams. This phenomenon is caused by high-energy cosmic rays piercing through the hull of the station, passing through the astronaut's skull, and physically striking the retina of the eye. It is a cosmic ray visual phenomenon. They are literally seeing the radiation that the weakened magnetic field failed to stop. It is a stark reminder that over this specific patch of ocean, the shield is almost gone. For machines, the situation is even worse. The Hubble Space Telescope is programmed to shut down its sensitive sensors every time it enters the anomaly. If it didn't, the radiation spikes would fry its electronics. Satellites frequently experience single event upsets, SEUs, here. A cosmic ray hits a memory chip, flipping a 0 to a 1, causing the computer to crash or reboot. We have lost satellites in this region. The Japanese satellite Hitomi spun out of control and disintegrated shortly after passing through the anomaly. It is a graveyard for electronics. As we rely more on satellite internet and GPS, the expansion of the SAA poses a $1 trillion threat. If this dent grows deeper, low Earth orbit could become a no-fly zone for our technology. But what is causing this weakness? To find the culprit, we must look deeper than the ocean floor. Seismologists using earthquake waves have imaged two massive continent-sized structures deep in the mantle. One is under the Pacific and the other is directly under Africa. They are called Large Low Shear Velocity Provinces, LLSVPs, or simply the blobs. The African blob is colossal, thousands of kilometers wide and denser than the surrounding rock. Some scientists hypothesize that these are the remains of Gaia, the ancient protoplanet that collided with Earth to form the Moon. If this is true, an alien world is buried inside our planet. This dense alien rock interferes with the heat flow from the core, disrupting the Geodynamo exactly under the South Atlantic, creating the magnetic dead zone. Recent data from the ESA Swarm mission shows that the anomaly is evolving. It is not just growing, it is splitting. In the last decade, a second center of minimum intensity has emerged off the coast of Africa. The original center remains over Brazil. The anomaly is bifurcating, creating a complex double-headed monster that covers a vast area of the southern hemisphere. This split suggests that the processes generating our magnetic field are becoming chaotic. It's not a simple weakening. It's a turbulent restructuring. This kind of complexity, multipole fields appearing, is exactly what computer models predict happens right before a pole flip. We are watching the gears of the planet grind and slip in real time. Closer to the surface, airline pilots flying routes between South America and Africa have reported strange navigational glitches. While modern planes use GPS, the backup magnetic compasses and older inertial systems drift more significantly in this region. But there are also reports of ghostly static radio blackouts and unexplained interference on high-frequency bands. While not officially recognized as a danger zone for aviation yet, the thinning magnetosphere means that passengers on these flights receive a higher dose of cosmic radiation than on any other route. It is a subtle, invisible hazard. As the anomaly expands northward, it will soon cover major air traffic corridors, potentially forcing airlines to reroute flights to avoid the radiation bath. The terrifying question is, how big can it get? If the African blob continues to disrupt the core, the SAA could expand to cover half the planet. We would effectively lose our shield over the daylight side of Earth. This would allow the solar wind to strip away the upper ozone layer, increasing UV radiation levels on the surface to dangerous heights. Skin cancer rates would skyrocket. Crops would fail. We look to Mars for a cautionary tale. Mars has no global magnetic field, only patchy crustal magnetism remnants, locked in the rocks, similar to our SAA, but planet-wide. Mars lost its atmosphere because it lost its shield. While Earth is larger and has an active core, the SAA is a glimpse into a Martian future. It is a window into a dead world. The impact on the ocean ecosystem in this region is largely unknown, but potentially devastating. We know that magnetotactic bacteria, ancient microbes that align with magnetic fields, live in these waters. They form the base of the food chain. If their internal compass fails or directs them downwards into oxygen-poor depths instead of upwards, it could trigger a collapse from the bottom up. Furthermore, sea turtles that migrate from Brazil to Africa use the magnetic field intensity as a longitudinal coordinate. They know how far east they are by the strength of the field. With the SAA weakening that intensity artificially, turtles might think they are thousands of miles away from their actual location, missing their nesting islands entirely and getting lost in the open ocean. The biggest fear is a synchronized event. Imagine a massive solar superstorm, coronal mass ejection, CME, hitting Earth exactly when the South Atlantic Anomaly is facing the Sun. The shield is already cracked. The storm would punch right through, inducing massive ground currents in Brazil and Africa. Electrical grids would melt. Pipelines would corrode rapidly due to induced currents. It wouldn't be a global apocalypse, but it would be a regional catastrophe that would cripple the economies of two continents. The SAA is the Achilles heel of our modern civilization, and the Sun has the arrow aimed right at it. The South Atlantic Anomaly is not an isolated accident. It is a symptom of a planetary fever. It is the first domino in a chain reaction that leads to the event we fear most, the Geomagnetic Reversal. The North Pole is running away. The South Atlantic is opening up. The signs are everywhere. In the next chapter, we will look at the mechanics of the flip. How does it happen? How long does it take? And most importantly, can we survive it? We will explore the Laschamp Event, a brief reversal 42,000 years ago that coincided with the extinction of the Neanderthals. Are we next? When we say pole shift, people imagine a clean, instant flip, like turning an hourglass. But the reality is far more chaotic. A geomagnetic reversal is a slow-motion car crash that takes centuries, perhaps millennia. During the transition, the dipole, the simple north and south, vanishes. In its place, a multipolar world emerges. Imagine having a North Pole over Paris, another over Tahiti, and a South Pole over Florida. Your compass would be useless. Navigation would be impossible. But the real danger isn't getting lost, it's getting burned. During this chaotic multipolar phase, the overall strength of the magnetic shield drops to as low as 5% of its current strength. We become naked against the cosmos. We know this happens because nature kept a diary. In 2019, scientists in New Zealand unearthed a massive kauri tree, preserved in a peat swamp for 42,000 years. This tree lived through the last major magnetic collapse, known as the Laschamp excursion. By analyzing the carbon-14 levels in its rings, they created a precise timeline of the atmosphere during the event. Carbon-14 is created when cosmic rays hit the atmosphere. Normally, our magnetic field blocks most cosmic rays. But if the field collapses, cosmic rays flood in, creating a spike in carbon-14. The kauri tree rings showed a massive surge in radiation that lasted for about 800 years. It was the Rosetta Stone of geomagnetic history, revealing exactly what happens when the shield goes down. The scientists named the crisis point of this excursion the Adams Event, after sci-fi author Douglas Adams, because it happened roughly 42,000 years ago, the answer to everything. During the Adams Event, the Earth's magnetic field strength plummeted to near zero. The Sun was entering a grand solar minimum, but despite the quieter Sun, the lack of a shield meant Earth was bombarded by ionized particles. The sky would have changed color. Auroras, usually confined to the poles, would have rippled across the equator. The atmosphere would have glowed with a ghostly ionized violet light at night. Frequent, massive lightning storms, superbolts, would have pummeled the surface as the atmosphere became electrically charged. It was an era of electric chaos. The most immediate effect was the collapse of the ozone layer. Without the magnetic field to deflect the solar wind, the charged particles stripped away the ozone. This allowed high-energy ultraviolet, UVB, and UVC radiation to hit the surface. This is not just get a tan weather. This is DNA damage weather. Any plant or animal exposed to the midday sun would suffer cellular damage. We see evidence of this in the fossil record. Pollen from that era shows mutations consistent with UV radiation stress. The forests would have struggled to grow. The food chain would have been under immense pressure. It was a planetary radiation burn. This timeline aligns perfectly with a major mystery in anthropology, the extinction of the Neanderthals. For thousands of years, Neanderthals ruled Europe. Then, around 42,000 years ago, they vanished. While humans, Homo sapiens, survived, our cousins died out. The Adams Event theory suggests they were the victims of the magnetic shift. Neanderthals had larger eyes and fair skin, evolved for the low light of Ice Age Europe. This made them incredibly sensitive to UV radiation. When the ozone layer collapsed, they might have suffered from cataracts, skin cancer, and immune system suppression. They were biologically unequipped for a high radiation world. They didn't just lose a war with humans. They lost a war with the sun. Meanwhile, our ancestors, Homo sapiens, did something strange at exactly the same time. We started painting in caves. The sudden explosion of cave art across Europe and Asia coincides with the Laschamp excursion. Why? The theory proposes that humans retreated into caves not just for shelter from the cold, but for shelter from the sun. The caves became our bunkers. But there is another detail: red ochre. Ancient humans began using red ochre sunscreen extensively during this period. Red ochre is iron-rich and blocks UV light effectively. Did our ancestors figure out that the sun was deadly and invent the first sunblock to survive the Adams event? It seems ingenuity saved us while biology failed in the Neanderthals. The climate also went berserk. The ionization of the atmosphere changed the way clouds formed. It shifted the jet streams. The Earth plunged into a volatile climate phase. Glaciers advanced rapidly. Australia dried up, leading to the extinction of its megafauna like the giant wombats and marsupial lions. The Laschamp Event teaches us that a magnetic reversal is not just a compass glitch, it is an ecological disaster. It reshapes the biosphere. It kills species that cannot adapt to radiation and rapid climate shifts. It is a filter. And we are currently entering the same cycle that wiped out our cousins. But there is a massive difference between 42,000 years ago and today. They had stone tools. We have microchips. The Neanderthals didn't have a power grid to fail. If an Adams event happened today, the UV radiation would be bad, but the loss of electricity would be fatal to our civilization. We are exponentially more fragile than our ancestors. We depend on a stable magnetic field for banking, communication, water pumping, and food distribution. A 5% field strength would mean that every solar storm becomes a Carrington event. Satellites would fall from the sky as the atmosphere expanded due to heating. The internet would essentially physically burn out. The data is worrying. Since we started measuring it in the 1840s, Earth's magnetic field strength has dropped by about 10 to 15%. The decay is accelerating. It is dropping 10 times faster than previously predicted. This rapid decline, combined with the movement of the poles and the growth of the South Atlantic Anomaly, fits the profile of the onset of an excursion. Are we in the early stages of the next Laschamp event? Geologically speaking, we are due. These events happen roughly every 200,000 to 300,000 years, but the last full reversal was 780,000 years ago. We are living on borrowed time. The engine in the core is overdue for a reset. The Laschamp event was a warning shot from history. It showed us that the magnetic heart of our planet can skip a beat. And when it does, the surface becomes a hostile alien world. But we are not Neanderthals. We have science. We can monitor the changes. In the next chapter, we will return to the modern ocean. We will look at how this shifting field is affecting modern technology right now. We will explore the World Magnetic Model, the software that keeps every plane and ship safe, and why the US military had to perform an emergency update because the North Pole moved too fast. The crisis is not in the future. It is in the software code we use today. The modern world runs on a piece of software called the World Magnetic Model, WMM. It is the standard map of the Earth's magnetic field, maintained by the US Department of Defense and the British Geological Survey. Every ship, every commercial plane, every military submarine, and even the Google Maps app on your phone uses this model to know which way is north. Normally, the WMM is updated every 5 years. It is a slow, predictable cycle. The last update was scheduled for 2020, but in early 2019, scientists realized something was wrong. The real-world magnetic North Pole was moving so fast that the software model had become inaccurate. The error margin was exceeding the safety limit for military navigation. They couldn't wait. For the first time in history, NOAA and the British military issued an emergency out-of-cycle update to the World Magnetic Model. The North Pole wasn't just drifting, it was sprinting. In the early 2000s, it moved at about 15 kilometers a year. By 2020, it was racing at over 55 kilometers a year. It has officially abandoned the Canadian Arctic, where it sat for centuries, and is now crossing the Arctic Ocean towards Siberia. This Siberian trap is unprecedented in recorded history. The pole is being pulled by a magnetic blob of intense flux deep beneath Russia, while its counterpart under Canada is dying. This tug of war is literally dragging the compass needle across the top of the world. If you use an old map or outdated GPS software today near the Arctic, you could be off by hundreds of kilometers. The impact is physical. Airport runways are numbered based on their magnetic heading. Runway 09 points east, 90 degrees. Runway 27 points west, 270 degrees. But as the magnetic field shifts, these headings change. Airports like Tampa International in Florida and Stansted in London have been forced to close runways to repaint their numbers. It sounds like a minor inconvenience, but in aviation, precision is life. If a pilot is landing in heavy fog, using instruments that tell him he is lined up with runway 28, but the ground has magnetically shifted to 29, the consequences could be catastrophic. The entire global aviation infrastructure is having to constantly recalibrate itself to chase a wandering target. It's not just planes. Your smartphone has a tiny magnetometer inside it, a microscopic compass. When you open a map app and see that little blue beam showing which way you are facing, that's the magnetometer talking to the world magnetic model. If the BOBUMM is wrong, your phone doesn't know where you are looking. In urban canyons of concrete and steel, GPS signals can bounce and get confused. The foam relies heavily on the magnetic compass to orient you. As the field weakens and shifts, the reliability of consumer navigation tech degrades. We are building self-driving cars and delivery drones that depend on this invisible grid. If the grid becomes unreliable, the autonomous future hits a wall. For the military, the stakes are higher. Submarines can stay submerged for months, running silent and deep. GPS signals do not penetrate water. They rely on inertial navigation systems, which are constantly cross-checked against the magnetic field map. If the map is wrong, a nuclear submarine could think it is in international waters when it has actually drifted into enemy territory. The emergency update of 2019 was likely driven by this fear. In a world of hypersonic missiles and precision strikes, a navigational error of even 1 degree is unacceptable. The shifting poles are not just a scientific curiosity. They are a national security threat. The planet is changing the battlefield parameters without asking for permission. The energy sector is also blind without the WMN. Modern oil rigs use directional drilling. They drill down and then turn the drill bit sideways to chase oil pockets kilometers underground. To know where the drill bit is pointing deep in the dark rock, they use magnetic sensors. If the local magnetic field is fluctuating or the model is outdated, they could drill into the wrong reservoir or, worse, crash into an existing well, causing a catastrophic blowout like Deepwater Horizon. The industry spends millions buying real-time magnetic data because the Earth is no longer offering a stable reference frame. While we can update our software, nature cannot. We return to the biological crisis. Homing pigeons, famous for their ability to find home from anywhere, are getting lost at record rates during solar storms and magnetic anomalies. In races, release events have seen losses of up to 40% of the birds. They are the canaries in the coal mine. Their confusion signals that the signal-to-noise ratio of the planet is degrading. If the North Pole crosses into Siberia and eventually flips, what happens to the monarch butterflies, the geese, and the whales? Evolution is slow, the magnetic shift is fast. We might be facing a navigational extinction event, where species simply cannot find their way to survive. Scientists have identified a phenomenon called a geomagnetic jerk. This is not a slow drift, but a sudden sharp acceleration of the field chain, like a car lurching forward. These jerks are unpredictable and usually happen every decade or so. But recently, they seem to be occurring more frequently. The 2016 jerk is partly what led to the 2019 crisis. These jerks are thought to be caused by hydromagnetic waves emitted from the outer core. Imagine a tsunami of molten iron crashing against the solid mantle deep below our feet. The shock wave travels up and snaps the magnetic field lines. We are standing on top of a storm we cannot see. The scary truth is that our ability to predict the magnetic field is limited. We are trying to forecast the weather of a molten ocean 3,000 kilometers down, using only sensors on the surface. We are reacting, not predicting. The 2019 emergency update proved that the Earth can surprise us. If a massive jerk or a rapid acceleration happens next year, we might lose GPS accuracy globally for weeks until a new model is built. In our just-in-time economy, where delivery trucks and Uber drivers rely 100% on navigation, a glitch in the WMM is a glitch in the global economy. We have seen the symptoms: the wandering pole, the dent in the South Atlantic, the confused whales, and the panicked generals. But to find the cure, or at least the cause, we must go to the source. We must dive into the D layer, the mysterious boundary where the liquid core meets the solid mantle. In the next chapter, we will explore the deep Earth blobs and the terrifying theory that the Earth's core is becoming lopsided. Is the dynamo dying, or is it just resetting? And what role does the ocean play in cooling this planetary engine? The answers lie in the fire below. To understand why our magnetic shield is failing over the Atlantic, we must descend to the most chaotic place on Earth, the core mantle boundary, CMB. This is 2,900 kilometers beneath your feet. It is a landscape of hellish pressure and temperature, where the molten iron ocean of the outer core crashes against the solid rock ceiling of the mantle. Scientists call this the D double prime layer. It is not a smooth sphere. It has anti-mountains roots of rock hanging down into the liquid metal, some higher than Mount Everest. It is here, in this violent interface, that the fate of our magnetic field is decided. The flow of the liquid iron must brush against this rough ceiling, creating the friction and turbulence necessary for the dynamo to work. But the ceiling is not uniform. Seismologists analyzing earthquake waves discovered two colossal anomalies sitting on top of the core. They are formally called Large Low Shear Velocity Provinces, LLSVPs, but scientists simply call them the blobs. One sits under the Pacific Ocean. The other sits directly under the African continent. These blobs are titanic. The African blob alone is twice the size of the Moon. They are denser, hotter, and chemically different from the rest of the mantle. They are essentially continents within the Earth, and ominously, the African blob sits exactly underneath the South Atlantic Anomaly, the weak spot in our field. This is not a coincidence. The Geodynamo works on convection. Hot iron rises, cools down at the boundary, and sinks back down. This looping motion creates electricity, but the African blob acts like a giant thermal blanket. Because it is so hot and dense, it insulates the core underneath it. It prevents the heat from escaping into the mantle. If the heat cannot escape, the molten iron underneath cannot cool down. If it doesn't cool, it doesn't sink. The convection loop stalls. It's like putting a lid on a pot of boiling water. The churning stops. Under Africa, the Earth's magnetic engine is effectively clogging up. This stalled engine creates a patch of reversed flux, a magnetic dead zone that projects upwards to create the South Atlantic Anomaly. What are these blobs? The leading theory is terrifying. They might be the corpse of another planet. 4.5 billion years ago, a Mars-sized protoplanet named Theia collided with the early Earth. The debris formed the Moon. But what happened to the core of Theia? Simulations suggested punched through the Earth's crust and sank, intact, to the bottom of our mantle. If this Theia impact hypothesis is correct, the African blob is literally an alien graveyard. We are living on a hybrid planet. The dense fragments of that ancient alien world are still down there, sitting heavily on our core, disrupting the flow of our magnetism billions of years later. The dent in our shield is a scar from a cosmic collision that happened at the dawn of time. The presence of these alien obstacles forces the liquid iron to flow around them, creating chaotic eddies and whirlpools. Imagine a river flowing smoothly until it hits a giant boulder. The water becomes turbulent and unpredictable. The geomagnetic jerks we discussed earlier, the sudden shifts in the North Pole, are likely caused by these fluid packets hitting the edges of the blobs. This turbulence creates reverse flux patches. Instead of the magnetic field pointing north, small eddies point south. When these reverse patches grow strong enough under the Atlantic, they cancel out the main field, creating the weak spot. The African blob is essentially generating a localized anti-North Pole that fights the main dynamo. The battle isn't just about flow, it's about freezing. The very center of Earth, the inner core, is a solid ball of iron growing larger every year as the planet cools. It grows by crystallizing the liquid outer core. This crystallization releases heat, which powers the dynamo. But the growth is lopsided. Seismic studies suggest the inner core is growing faster on one side, under Indonesia, than the other, under the Americas. This asymmetry makes the magnetic field unstable. The dynamo is unbalanced, like a washing machine with an uneven load. As it spins, it wobbles. This wobble is driving the rapid drift of the magnetic North Pole toward Siberia. The engine is vibrating itself apart. Seismic studies suggest the inner core is growing faster on one side, under Indonesia, than the other, under the Americas. This asymmetry makes the magnetic field unstable. The dynamo is unbalanced, like a washing machine with an uneven load. As it spins, it wobbles. This wobble is driving the rapid drift of the magnetic North Pole toward Siberia. The engine is vibrating itself apart. When a cold slab hits the core, it extracts a massive amount of heat rapidly. This kickstarts the dynamo, making the magnetic field stronger. It is a planetary thermostat. The Pacific Ring of Fire is not just volcanoes. It is a cooling system. But under Africa, there are no subduction zones to cool the core. There is only the hot, insulating blob. The lack of ocean cooling in that region contributes to the failure of the field. All these factors, the alien blobs, the lopsided crystallization, the stalled convection, point to one outcome: instability. Computer simulations of the geodynamo show that when the flow becomes this complex, the field inevitably tries to reverse. It is the only way for the system to shed the built-up magnetic stress. We are seeing the classic precursors. The dipole, two-pole system is weakening, and the multipole, complex system is gaining strength. The African blob is winning the war against the main dipole. The South Atlantic Anomaly is not just a dent. It is the seed of the new South Pole. The reversal has effectively already started. It just hasn't finished flipping yet. So what happens next? If the blob continues to strangle the convection currents, the anomaly will expand. Models predict it could merge with other weak spots, covering the entire southern hemisphere in a low magnetic zone within just a few centuries. This would leave half the planet exposed to higher radiation levels. It wouldn't be an instant, day after tomorrow freeze, but a slow grinding degradation of our technological capacity and biological health. The magnetic heart is suffering from a blocked artery, and we don't have the technology to perform bypass surgery on a planet. We have journeyed from the wandering pole on the surface to the alien graveyards in the deep. The picture is clear. The Earth is a dynamic living entity, and it is changing. The stability of the Holocene era, the calm period in which human civilization flourished, might be coming to an end, magnetically speaking. In the final chapter of this documentary, we will look at the ultimate question: can we survive the flip? We will explore the possibility of artificial magnetic shields, the future of human evolution under high radiation, and the philosophical implication that our North is not as permanent as we thought. The inevitable question remains: if the poles flip in our lifetime, can civilization survive? The answer is yes, but not without change. We are not the Neanderthals. We have the power of engineering. The most immediate solution is hardening the grid. Power companies are already installing capacitors to block the massive DC currents induced by solar storms. But for individual survival, if the radiation levels spike, we might look downwards. We already build underground bunkers for war. In a magnetic crisis, subterranean living might become the norm for vulnerable populations. Or perhaps we will build cities under domes made of radiation shielding materials, living in bubbles on our own planet, much like a colony on Mars. There is a bolder, more sci-fi solution: an artificial magnetosphere. NASA scientists have proposed this concept for terraforming Mars, but we could use it for Earth. By placing a massive superconducting loop at the Lagrange point L1, a stable gravity spot between Earth and the Sun, we could generate a magnetic field strong enough to deflect the solar wind before it even reaches us. This planetary shield would act as an umbrella. It wouldn't fix the broken dynamo in the core, but it would buy us time. It would artificially replace the protection we lost, keeping our atmosphere intact and our satellites safe. It is a mega engineering project, costing trillions, but compared to the collapse of modern civilization, it is a bargain. Biology might also find a way. Evolution is resourceful. In the ruins of the Chernobyl nuclear reactor, scientists found fungi that don't just survive radiation, they eat it. These radiotrophic fungi use melanin to convert gamma rays into chemical energy. If the magnetic shield fails, life on Earth might evolve to be darker. Melanin protects against UV radiation. Plants might become darker to shield their DNA. Humans might rely heavily on genetic engineering to boost our own DNA repair mechanisms. We might become a species that thrives in the high-energy environment of a shieldless world. As we conclude this journey, we must change how we see our home. The Earth is not a rock floating in space. It is a dynamic electrical entity. The ocean is its blood, conducting the currents that stabilize the field. The core is its heart, beating with the rhythm of a dynamo. And the magnetic field is its breath, expanding and contracting, protecting the fragile life on its surface. The shifting of the poles, the anomalies, and the jerks, these are not errors. They are the vital signs of a living planet. A dead planet like Mars has no pulse. A living planet is chaotic. The shifting North Pole is proof that the engine deep below is still running, still churning, still alive. The mystery of the ocean's magnetic heart is far from solved. We are just beginning to understand the connection between the salt water above and the molten iron below. As the anomaly grows, we will be watching, we will be measuring, and we will be adapting. If this deep dive into the electromagnetic soul of our planet sparked a current in your mind, please subscribe and join our community. We explore the darkness to find the light. Leave a comment below. Do you think we will see a pole shift in our lifetime? I read every theory. From the ghost signals in the Bermuda Triangle to the frozen history in the Koray trees, from the panicked compasses of the Arctic to the alien graveyard in the mantle, the Earth is speaking to us. The question is, are we listening? Thank you for watching Nightlight Science Stories. Keep your compass true and never stop exploring. Good night.